Hey guys, tonight we're going to be going over the installation of the guy wire kit that we're promoting on the website, and it stabilizes the top gantry or the top portion of the frame on the CR10. When you get up into the higher prints, you have all that weight going back and forth, and it sets up sort of a momentum with the glass going back and forth, which is basically just a big rock, all that weight going back and forth, and it sets up kind of a whip pattern to it, kind of a resonance, let's say. And I have some prints that I've noticed I've printed in the past, and they set up that resonance, and I put some of them on the build plate tonight, and I have a phone app called Vibe Sensor on my smartphone. And we're going to have a little fun tonight. We're going to do a little experiment, and I have 2 minutes duration of segment of data collection that we're going to do with the gantry guy wires on and without them on. There's going to be no hocus pocus. I'm not going to change the speed of the print or anything on it. You'll be able to see how it performs with and without that, and the importance of having that on your machine. So stay with me. We're going to have a little bit of fun. Hopefully we're going to learn something together tonight. I've done this experiment on another machine, and I was really surprised what it revealed. It also revealed it changed the amount of momentum on the z-axis going up and down too. This will measure that also. So we're just going to look that data over and analyze it, and we'll see what we come up with. It'll be a big surprise to me too, so stay tuned. Thank you.
Hey, ladies and gentlemen, it just went into the top part of this print. I just want to show you what we're doing here. The first time I did this at my machine, I thought it was falling apart. This is just evil. It goes across the top of that rim of these little, these are keepers for my for a little touch bed leveling system that I've got here. And the first time I did this, I thought there was something wrong. So we're just going to go ahead, and I'm going to start. We're going to 10-second pause. And this is that acquisition program here. I'll try to hold this as steady as I can. Pay attention. We'll show the X, Y, and Z. Here we go. I was surprised the first time I did this because of how much Z movement there is, and you can see the Y is pretty brisk. Very sensitive. When I hold this in my hand, I can actually see my heartbeat. Believe it or not, it's a very sensitive program. So we're going to get this data, 2 minutes worth, and then we're going to compile it and compare these. It'll come out in graph form. This is with the gantry stabilization on it. The name of the program is, I believe it's VibraSense. I'll put that down in the information down below the video. I'm just about at the tail end here. Okay, now we are going to, while this is running, I'm going to go ahead and I'm going to go off camera, disconnect the wiring or the cables to the to this system right here. You can see the guy wire system set up over here. These are the wires that are kind of hard to see, so I'll be right back. Okay, there's my guy wire system pulled down. I'm going to start this again, and we're going to require 2 minutes. Probably can't see this. I'm going to go off camera just for a second here. We'll be able to see the data later, but I can actually see my phone shaking. Not real clear. No, it's not picking that up. I don't know if you're picking that up. I can see it. It's kind of blurring in the camera here. It's shaking back and forth so fast. Okay, we have our data.
While I originally set out to graph and compare data, I realized this app turned my phone into a very delicate instrument, judging on how it could actually measure my pulse when I held it in my hand. The data literally went off the charts when connected to my CR10. I did glean some valuable information from it in that the frequency shown in my data has risen, and after seeing hundreds of demonstrators on frequency and vibration, it came down to the lower the frequency, the more and bigger the oscillations. The higher the frequency, the smaller oscillations. Therefore, let me demonstrate and put this in perspective for you.
So let me put this in sort of a nutshell for you, if you will allow. I may be oversimplifying this, but listen to the tone of this while I do this too. And watch the... Now my phone has stabilization on it, so that's going to take a little bit of that motion away. So we've got just about twice as much hanging out. And you can see by the momentum of the sheer momentum of all the weight on the end of it going back and forth and carrying that all the way to the rest of the machine. So you're basically causing a resonance with this. So this is the best way I can put this in a nutshell. It's pretty simple when you look at it. If we were to tie this on the end to a stable part of the machine and try this, we would have no vibration. And
we are assembling our what we call our guy wire kit. Consists of a center bracket that mounts to the top of your CR10's tower. This is printed with real high density infill. And rather than put a bunch of fish around for a bunch of nuts and bolts, I assembled these in sub-assemblies. This will give you some idea of how this is constructed. These are also high fill printed. And this is a piece you'll see that assembles with the hammer nuts or the lock nuts into your extrusion. Everything's pretty simple. So I'll just run along this thing real quick. While I've got this out, this is a special, it looks like a guitar tuner. This is a special one that has a vise, and this knurled nut here will capture the string, or the wire I should say. This is not music wire, but it is, it doesn't have to do much, just keep the vibration up on top, keep that from swinging back and forth. So we don't want to tighten this down too much. It will have a tendency to pull down on the middle of the extrusion. So I'm going to go through this with you real quick. Real easy to do this, and let's get started. So the only tools you actually need for this are 3 Allen wrenches that come in your kit. I believe 2.5, 3, and 4 millimeter. And all of the rest of the bolts are supplied here. You've got plenty of wire to do run this a couple times over. So let's get started. All right, line these nuts up. Just slip that in there. Pull it all the way back. You take your 2.5 millimeter Allen wrench. Just make sure that hammer nut swings into position 90 degrees or perpendicular to the track, and you can feel it when it does. It'll tighten up right away. If you have to keep screwing on it, it's usually not tightening up on you. So okay, and that's good and sturdy. Same thing with this. It flips in, slide all the way back. Just going to double check our torque. Okay, we're ready for the center. Now you have a cap that comes on the end of this, just a trim cap. You'll just pull that off. Comes off real simple. It's held in with a little detent on the inside of this hole. The reason I mentioned that, this hole lines up with it. That keeps this bracket from sliding down when you put pressure on it. Should this during assembly, and should this nut come loose here, that's kind of a safety up there. So we're going to line the nut up. Make sure you just stick that in there. It should snap in there fairly easy. And we'll tighten this guy. Okay, he's in there. And then you have these, what we're going to call capture bolts here. 2 washers and a lock nut. The lock nut goes into a recessed area, a capture as they call it. So you keep the washers out here. And you just get it started. We're going to need that loose, to be loose for us to handle the wire, to run the wire through there. So you're ready for the wire. This is a pretty simple operation here. Just want to string enough of it out. I suggest wearing safety glasses or glasses of some type. You can't see this stuff coming at you. Okay. And string out about, I don't know, maybe 4 feet, and give you plenty here. And you're going to, as these top had a capture in them, excuse me, so will the bottom. Try to get this in focus here so we'll get everything together. The bottom, you'll want to just make sure you get it between the 2 washers. Okay, get yourself a couple inches. You can wind this around. Wind this back around on itself and just come under. And that's just going to tame it for you. And we're going to just tighten this. that just squeezes in between the two washers. And you want the trajectory to be pointed upward toward the upper bracket there. And nice and firm, that should be good. This wire's coated, and that helps it not slip. Helps it grip a little bit. Like watching Grandma thread the needle here. Okay. And we just run it between the washers on these two. And when you're sure you've got enough, you've got plenty of it here, we're going to give ourselves about extra 4 inches or so. Get my nippers, snip this off. Okay, you want the knurled nut on the back, just unscrew it counterclockwise as if you were looking at it directly. Okay, this part's kind of important here, so you want to string it through there and don't pull this tight. Give it about 1 inch or so back and wind this way and then cross over back over on itself, and then tighten your vise on the back. You could shear that off if you tighten it too much, so we're just going to get it snug. It just has to hold that wire while this is gripping it. So not to over tighten this. You do not want to play a tune on this. These have to be equal. Probably want to favor pulling it in this way. You get a lot of leverage on this. It's geared down quite a bit. Just be careful with that. Okay, now you just want to stop this from vibrating back and forth. So you want that to be kind of flat. Okay, you can tighten this as you go, but it's very important right now at this point just to kind of let this float in here. If you do tighten this up, be cognizant if you manually level your bed that you will change the level on your bed. This is actually pulling down on the top beam, and you're going to get your nozzle a lot closer to this. So just be prepared for that. When you do level it, you want to install these first. Back off on your levelers, and go ahead and try the level on it. This is amazing. This is probably the biggest thing you can do for your machine, bar none. This is really, they kind of fell down on this part of the design. If you ever watch where people will give feedback on these machines, a lot of times they'll get all caught up in this. They get a free machine from Creality or GearBest or somebody, and they'll give a little rant about it. What I've noticed, if it's in the vase mode, they'll always print a real tall vase. If it's in vase mode and it's going around nice and smooth, you won't get this vibration issue. But if you print real stuff like I do, you will get ringing, and even at lower levels. It's not that it just happens at higher levels, but it's more pronounced. You have more movement up here than you do when it's at the bottom. You will notice an improvement immediately. One thing I'd like to say about this, of course, we do the other side also. To really complete this, and it's not mandatory to put this on, this is another kit that I have that we feature, and we'll also do the test on that. What happens is when you put this load on it back and forth, you're not making the load go away. You're actually transferring this load slightly to the up and down movement in the Z direction. So to stabilize that, I've got rubber feet that will isolate that vibration, put this in contact, and and you stabilize the whole platform. You actually bring it together as one piece. Anything that is designed well has a triangulation engineered into it. In other words, all the points meet in triangles on it, and it carries all of the load through the entire frame. Bicycle frames have it, motorcycle frames, you name it, but the Creality CR10 doesn't have it. So it has it now. If you have any questions about this, feel free to call. I have a direct email that comes in. I'm Dave Aschenbrenner. My email is technical at 3D print to form. I'm just going to give you a little shot of this. These are your rubber bumpers and shims. These are all what they call hammer nuts. You have washers to back these up. You have a hammer nut. You have 2 of these for each rubber piece, and you can shim them for distance. So if you pull this down a little bit, you put less washers in the middle here. Maybe more on the outside where there's no pressure pulling down on it. So please give us a call if you're looking for anything that enhances the performance of your CR10 or any clone, anything like it. We make these parts right in-house. These are made right in the United States. Or if we do get parts from overseas, we pick the finest quality pieces that are available. So give us a call. Appreciate your time. Thank you. Well, there you go. I hope everyone got something out of this, and try to explain this in a way that could relate to what's happening with the machine and the leverage that we've overcame with the guy wires. We're basically, when we get into the subject of vibration, it's a whole nother subject that deserves its own video, and to really hunt this out. In fact, when I went looking for information on this, I was surprised at what I found. A lot of it was professors standing in front of a blackboard doing calculus problems. And if we were designing something, that's one thing, but with the CR10 we have a bunch of givens, non-variables, and each one of those parts, if we can just use common sense and put physics on our side to try to brace this up in the way that it just makes it a more solid machine. It's pretty easy to see the cause of this is the momentum of the glass plate, and that's a given. We can change that by putting something lighter on it. In fact, I've got copper that I use on mine. The build plates will be a whole another subject here. But the guy wire kit, which is what we're concentrating on, really helps this machine out. And if each one of these little things that we can do to the machine helps it just a little bit, we can turn the speed up. We can really turn that CR10 into a little monster that just gobbles up plastic. So that's what I'm trying to do right now, help everybody do that. I've got some real exciting stuff coming up, one of which I'm excited about. I'm gathering some information on. I'm waiting for some patents to come back before I show it. It is a touch bed leveler system. It uses the nozzle to touch the bed. There's not a bunch of hoopla. There's no offsets where there's a sensor over here. You don't have to hook voltage up to it or anything. You merely hook the wires from your end switch up to it and put a little routine in the G code and press a button. Once you adjust it, you set your differential for tip touches it. It's set it and forget it. You put your part on and walk away from it. I just can't say enough about it, but that's for another time. I hope to see you soon in a video, and I hope that's the video that we see. So thanks for being with me, guys, and I appreciate you coming here and watching my stuff. I like doing this, and I like doing it for you, so show me some love and hit the like it button. Thank you very much.